a few years ago. So Sean has a loan of $800,000. The loan has a duration. The duration was a 6-year duration, and the loan has a down payment of 25% of the cost, so which is 200,000, right? So there's a down payment of 200,000 on an $800,000 loan. Sorry, on an $800,000 house. So the rest of the amount is on a 6-year loan with an interest rate of 7% per annum. Okay. Now that's one loan that Sean has. Another option is another thing that Sean is doing is Sean is now buying a car worth $60,000, and he is going to finance this car using a 1-year loan with an interest rate of 12% per annum. Okay. And both loans are to be paid back in EMIs. So what is the total monthly payment that Sean has to make? Okay, looks a little bit complicated, but if we break it down, there are just 2 loans going on here. So here is the first loan. Cost of house is such and such. The 6 years is the duration. 7% is the rate of interest, and 25% of 800,000 is the down payment. We simply put it into the loan EMI function, and we get back the EMI of the house as $10,230. Here is the second loan. So we have a $60,000 loan. The duration of the loan is 12 months. So 1 times 12. And the rate of the loan is 12% per annum. So we need to divide it by 12 to get the monthly rate. And then we put it into loan EMI. And that's it. That we get back the EMI for the car is $5,000 per month. And now we can display the total EMI that Sean makes a total monthly payment of the EMI of the house plus the EMI of the car towards loan repayments. Okay. So yeah, that's great. We've solved another problem using just these 1, 2, 3, 4, 5. This is technically just one line of code split across multiple lines. So 5 lines of code for the first loan and 4 or 5 lines of code for the second loan, and the problem is solved. Okay. Let's try one more. This one is a little more interesting. So here what we have is, if you borrow $100,000 and you are on a 10-year loan and you have a rate of interest of 9% per annum. So what is the total amount that you end up paying as the interest? So over and above the principal, the $100,000, what is the additional amount that you end up paying? So there's one simple way to do this. And what we can do is we can assume that there are 2 loans, one with interest and one without interest. Okay. So here's the loan with interest. It has the value amount of 100,000. It has a duration of 10 years and it has a rate of interest 9% per annum. So that gives us 1267 is the EMI with interest. Okay. Now let's suppose that there was no interest on this. So what we can do is we can simply get the EMI for the loan without interest. And then if we subtract the 2 EMIs, we get to know how much interest we are paying per month. And then we simply take that over the entire duration. So that gives us the total interest, right? So that's one way of solving it. There are other ways too. So let's put in the amount 100,000. Let's put in the duration and let us put in the rate of interest as 0. Oops, but something seems to have gone wrong here. And let's see what went wrong. Now this will happen to you a lot before you get better. And even after 12 years of doing Python, I still get exceptions all the time. So don't worry if something goes wrong. Just where you want to start is look at the last line. So it seems like this is a 0 division error. So what happens is whenever you try something that causes something to break while the code is executing, Python throws an exception. By throws, what it means is wherever the error occurred, it is going to stop the execution of the program there. And then it is going to just print out this error message for you. So it seems like there was a 0 division error. We were trying to divide by 0. And float division is simply the normal single division. So we are trying to divide by 0. Where were we trying to divide by 0? That is where you now go up and see that, okay, within the loan EMI function, if you check the third line, this is where this arrow points. So in this formula, it seems like we are dividing by 0. And now you can probably guess, because the rate is 0, 1 plus rate becomes 0. And because 1 plus rate becomes 0, 1 plus rate becomes 1. So 1 plus rate to the power of duration becomes 1. And 1 minus 1 becomes 0. So this entire denominator is now 0. And that's a problem because now dividing by 0 is not defined. And so the loan EMI returns an error. And that is why the EMI without interest, the code execution stops at this point and nothing gets printed. Okay. What do we do? So when an exception is thrown, when an exception is thrown by Python, you have a chance to actually handle that exception. And an exception, the way to handle it is using a try statement. Okay, so here's a small example. So what you do is you say try whenever you're writing some code which you think might cause certain errors. So you say try, and then here I'm going to print a statement saying computing the result, and then I'm going to divide 5 by 0. Bad idea. It's going to break here, and then I'm going to just say computation was completed successfully. So now, since I know that this might break, because maybe 0 came in as a function argument or something like in the previous function. So when I know that this is going to break, I can put in an except statement and put in the type of error that I might expect. So the except statement, and then the type of error is a 0 division error. So here what it is saying that if you get a 0 division error while executing this code, then do this. So what we do is we print that we failed to compute the result because you were trying to divide by 0, and then we set the result to none, and then we simply print the result out. Okay, so you can see here it says now computing the result. It tries to compute the result and it blows up. Now the print statement, this one does not get executed because we've broken out of the execution, but the except handles the error, and then these two statements get executed. So we say that you failed to compute the result, and result has the value none. This, on the other hand, if I were doing 5 divided by 2, so now this runs normally. So we never come into this error case, and we simply print out that the computation was completed successfully and the result has the value 2.5. Okay. And this is what you can do. You can actually have multiple except statements if you know that there can be multiple types of errors or exceptions that can be thrown. And Python has a lot of different exceptions. So you can actually check out, I've pointed to a link here. You can learn about more exceptions in Python. But what we want to do is we want to just take the loan EMI and add the try except inside it. Okay. So what we want to do is we want to try to calculate the EMI for the loan using the formula that we had. But if that returns an error, especially if it leads to a 0 division error, then we can say that the loan, if the 0 division error will occur only when the rate is 0. And when the rate is 0, you can simply divide the loan amount by the duration. So then we simply divide the loan amount by the duration. And that handles the error for us. Then we again round it up and then we return it. Okay, so that's great. So now we can use this updated loan EMI function. Once again, the question was you borrowed $100,000 using a 10-year loan with a rate of interest of 9%. What is the total amount you end up paying? So we calculate the EMI with interest, and then we calculate the EMI without interest. And this time it works even with the rate of 0. And then we can see that, okay, there's a difference, a significant difference with and without the EMI. So we do the EMI with interest minus the EMI without interest. And then we multiply it with the duration of the loan, which is about 10 years, right? So 10 times 12, those many months. So that gives us the total interest that is paid. And now we can display that the total interest paid is 51,960. Okay. And that's a good thing to know whenever you're taking a loan. What is the total interest you're going to end up paying? And are you okay with that versus just paying it? All right. So one last thing now, we can also add some documentation within our function using what is called a doc string. So this is what we saw the help method that we used with the seal math.seal. Okay. Now, how do you, if you want to add your own, if you want to add explanations within your own functions, and you should do that, the way to do that is to include a string as the first statement within a function. So here I'm using a multi-line string. So here I'm going to say that it calculates the equal monthly installment for a loan. So that is a description of the function. And by the way, you can just write that and that should be good enough too for a lot of things. So you do not need this necessarily. But anyway, I'm going to use this too. I put in one line about the function, then I am just giving a space just to make it a little clearer. And then I'm saying, I'm going to just describe the arguments as well, that the amount is the total amount to be spent. So here I might want to specify that do not this should be the loan amount plus down payment that you're putting in. Then the duration is simply the duration of the loan, but in months. So that's an important detail to give. And then the rate is the rate of interest, but it's monthly. And then finally, the down payment is an optional argument. It is an optional initial payment deducted from the overall amount. Okay. So this is how you, this is how you document a string, document a function. That is, explain what it does for the people who are going to use this function. And the rest of the body of the function is the same, right? So the rest of the things just go in the body. Now, when you have the documentation, you can simply call the help function, and you can see that the same documentation gets printed. This is very useful. It will be useful for you. It will be useful for others using your function. It will be useful for people reading your notebook as well. So whenever possible, write documentation for your functions. Okay. And now we can just save and upload our notebook. So again, since this is running on Binder, I don't want to lose my work. So I'll just grab my API key here and put it in. And as you keep committing notebooks to your profile, they will get added up here. So you can see here, I have a bunch of these notebooks, and you can always come back and run any of these. And then if you commit again, then they will get updated. So each of these notebooks, you can see how many versions they have and so on. And you can also share these notebook links online with your friends. If you want to just say, give a quick tutorial or answer a question specifically, even on the forum, if you want to answer a question and you can quickly create a notebook to do it. So you just do new notebook, create a new notebook, run it on Binder, type out the solution, and then commit it back. So once you get a notebook on Jovian, you can commit it back, and then you can simply share the result on the forum. Another thing to do is, if you're getting stuck at some point, then just commit your notebook and take the notebook link and post that on the forum saying that this is what I've tried and this is how I failed. Unless you describe what you have tried, it's very hard for people to help you out. Generic questions like, I'm not able to solve this problem, is not very helpful because people will not be able to help you. So the best way to get help is to offer as much description about what you've tried. And the best way to do that is to share the actual notebook that you have been using. Maybe just the piece of code that you are working with. Okay. So that's about functions, and there's a lot more to functions. So just a quick review of what we've covered, and I'll talk about an exercise for you. So we've talked about creating and using functions, and we've talked about creating functions with one or more arguments. And we've talked about local variables in scope and returning values using return, using default arguments, using named arguments while invoking a function, importing modules and using the library functions, reusing and improving functions to handle new use cases. So what we saw was we kept improving the loan EMI function over time. And this is something that you should do a lot, keep improving your functions. And we handled exceptions using try except. And then finally, we documented functions using docstring. So that's a lot of ground that we've covered in just 45 minutes. So I hope you've been able to follow. And if not, you have this notebook. So experiment with the notebook. So what you should be doing now, after the lecture, you should be going File, New Notebook, Python 3. Take this notebook, put it on one half of the screen. Take this other notebook, the existing notebook, and put it on the other half of the screen. Okay. And now what you should be doing is you should be actually typing out all of these things by yourself. So for instance, the loan EMI function, instead of just looking at the function and trying to understand it, you should be defining, you should be saying def loan EMI. And I'm just going to take the amount right now and return amount divided by 12. And then just try it out. Just try to break things. Just say, okay, what happens if I pass in loan EMI? I take a loan of $100. Okay, that seems to be the EMI. Now here you might get certain ideas. What if I pass in two arguments? What if I call it without any arguments? If you call it without any arguments, it says, oops, it's going to tell you that the loan EMI has one positional argument amount which you have not passed. You can try calling it with multiple arguments. That's going to give an error. So all of these questions that you might have, the more curious you are, the more you break things, the more you learn. And the best way to do that is to just type out the code yourself, because as you're typing, you will wonder, what can I change here? What can I break here? And the more you explore, the more you learn about Python, the better a programmer you will become. Okay. All right. So now we have an exercise for you. This is not an assignment or anything. This is just for you to understand. So here you're planning a leisure trip and you need to decide which city do you want to visit. So you've shortlisted 4 cities and you've identified what is the return flight cost and what is the hotel cost per day and what is the weekly car rental. Cars have to be rented for full weeks. So even if you want to use a car for 2 days, you still have to pay for the week, and hotels are rented per day or per night. And then you have the return flight, which is just a one-time cost. Okay. So using this data, and this is a real life example of, again, some analysis that you might have to do in real life. So using this data, if you're planning a 1 week long trip, which city should you visit to spend the least amount of money? Okay. So that's one question you can answer. And how does that answer change if you change the duration of the trip from 1 week to 4 days or maybe 10 days or 2 weeks? So it's a good thing to explore all these things. If your total budget is $1,000, then which city should you visit to maximize the duration of your trip? or maybe you actually do not have a lot of time, but you'd have a good budget. So which city should you visit if you want to minimize the duration of your trip? So these things are something that you can figure out, and then you can change the budget, try $600, try $2,000, try $1,500, and all of these things. And to do this, it will be very useful for you to define a function like cost of trip, which will take in all the relevant inputs like the flight cost, hotel rate, car rental rate, and duration, and it will calculate the duration of the trip. All right, and calculate the cost of the trip, and then you can use that to answer all of these questions or any other questions that you may have. So do try this out. This is going to be a good exercise on functions. And what we will do next time is we will continue working on functions, but we will also see how to work with files. So we will process some files, and then we will perform certain data analysis and certain operations from data read from these files. What should you do next? Try out the notebooks yourself. As I said, open up side by side and then type out the code. Start working on the assignment. So assignment 1, once again, just to repeat, you go on the lecture page zero2pandas.com, click open here on assignment 1, and run the notebook, make some changes, commit it back to Jovian, take the Jovian link and submit it here. So we'll take your last submission and evaluate it, and based on that we'll give you a pass or fail grade, and that will be done. Another very important thing to really learn things well is to ask and answer questions on the forum. So I would suggest make it a point to answer questions on the lecture forum thread, which you can access from here. So here's a discussion forum thread, or in general from the course page, you can just find the course community discussion forum. So you can click through to that link as well, and you can find all the discussions that are happening, lecture 2, assignment 1, lecture 1, and so on. And just try and at least ask one question per week and answer maybe 2 or 3 questions per week. The more you answer, the better your understanding becomes as well. So please do that. A lot of people are helping each other. So I just want to give a shout out to everybody who has been helping out. Talk to people on the forum, ask questions, try your own ideas, try to break the code. The more time you spend on this, the better you will get at it. So I will see you on the forums. We're looking at numerical computing with NumPy. So you can click the open link here, and that will open up the lesson page. And on the lesson, you will be able to watch the video now and later. And you also have the option to watch the same video in Hindi. Now, if you have questions during this lecture, you can ask these questions on the discussion forum. So there is a link to the discussion forum. So this is the discussion forum, and you can log into it with the same ID that you used to enroll for the course. And you can just ask questions here. You will see a big blue reply button here on the bottom. So just click the reply button and ask a question. So now I'm going to open up the first notebook. So the topic is numerical computing with NumPy, and this is a notebook you can open up. So here now I'm going to run the notebook. If you're joining us live, you need not run the notebook right now. Please don't, because there are thousands of us. So that may slow things down a little bit for everyone. So I'm just going to run it right now, and you can run it later after the lecture. So we click run, and then we click run on Binder to take this Jupyter notebook, which you're looking at here, and then run it online. So when you click the run button, it may take a couple of minutes to start up. This is because this is a free online service and it is provisioning some servers for you. Okay, so while it gets started, let us just go through some of the material. So this course is called Data Analysis with Python, and the data in data analysis typically refers to some numerical data. So things like stock prices, sales figures, sensor measurements, weather data, sports scores, database tables, and things like that. Now the NumPy library provides specialized data structures and functions and other tools for numerical computing in Python, that is working with numerical data. All right. The Jupyter notebook is now opened up. So this is running on Binder on an online platform. You can also run this on your own computer, and there are instructions here to run this on your computer locally. So I'm just going to open up this Jupyter notebook right now. The first thing I always like to do is go kernel and restart and clear output. This is to clear all the outputs from the previous execution so that we can see the outputs fresh. And I'm just going to hide the toolbar here so that you can see it better. All right. As I was saying, NumPy is a library that helps us work with numerical data in Python. So why we might need NumPy, since Python itself also supports a lot of arithmetic operations and things like that. Let's look at that using an example. So let's say we want to use climate data, so things like temperature, rainfall and humidity in a region, to determine if the region is well suited for growing apples. Okay, so a really simple approach for doing this would be to formulate the relationship between the annual yield of apples. So let's say in tons per hectare. So whatever is the annual yield of apples in a region, we relate that to the climatic conditions like the average temperature, which would be probably in degrees Fahrenheit, the average rainfall in millimeters, and the average relative humidity, and formulate that as a linear equation. So we could assume that the yield of apples is some weight W1 times the temperature plus some weight W2 times the rainfall plus some weight W3 times the humidity. So we are expressing the yield of apples as a weighted sum of the climatic conditions. Now obviously this is an approximation because the actual relationship may not necessarily be linear, because this is a linear equation, but a simple linear model like this often works really well in practice. And then what we might do is we might do some statistical analysis of the historical data. And based on that, we may be able to come up with a reasonable set of values for the weights W1, W2 and W3, right? So just based on looking at some historical data. So here is an example set of values. So now you have these weights W1, 2, 3. Now, given some climate data for a region, we can use these weights to predict what the yield of apples in the region might look like. So here we have the data for 5 regions. And let's say we want to identify what might be the approximate yield of apples in Kanto. So for that, what we can do is we can convert this information into variables. So the temperature, rainfall and humidity, all of these become variables. And then we can substitute these variables into the linear equation, the formula, to predict the yield of apples in that region. So here the yield of apples in Kanto becomes the temperature times W1 plus the rainfall times W2 plus the humidity times W3. And once we do that, we get back the result 56.8. And we can print it out that the expected yield of apples in the Kanto region is 56.8 tons per hectare. Okay. So far, it's a pretty simple calculation that we've done with a bunch of variables, but to make it slightly easier to perform the same computation for multiple regions, what we can do is we can represent the climate data for each region as a list of numbers, or what in mathematics is also called a vector, because otherwise we might end up creating a lot of variables. For 5 regions, we end up creating 15 variables. For 50 regions, we end up creating 150 variables, and that's just a lot of code to write. So rather, what we are going to do here is we're going to say that the Kanto region is represented by this vector or this list of numbers. The first number represents the temperature, the second represents the rainfall, and the third represents the humidity. Then similarly, we represent all the other regions also using these vectors. And again, temperature, rainfall, humidity are the 3 elements of the vector. Further, the set of weights that we've used, W1, 2, 3, those can also be represented as a vector together. So now we have the region, each region is a vector, and and the set of weights is a vector. So we can now write a function crop yield to calculate the yield of apples, or any other crop for that matter, because you just have to change the weights for a different crop. So we can calculate the yield of apples given the climate data and the respective weights. Okay. So here we have a function which takes the which takes the region, it takes a set of weights, and then it performs some calculation and returns the result. So let's observe what it does. So maybe let's just look at the Kanto region and let us look at the weights. So what we want to do is we want to multiply the first element 73 by the weight 0.3. Then we want to multiply 67 by 0.2, and we want to multiply 43 by 0.5. So in some sense, this is an element wise multiplication. And then we want to add up each of these products. So we get 3 products, so we add them up. So the way we do that is we set a result to 0, and then we use this zip function. So this zip built-in function returns pairs. So you can actually check what zip does. Let's see. So we say for item in zip, Kanto and weights, we simply print the item. So it turns out that it creates pairs out of the two lists. So it returns 73 and 0.3, 67 and 0.2, 43 and 0.5. So since these are pairs, or what we call tuples in Python, so these tuples can be converted into variables. So I can pull out the variables x and w. So x would have the value 73 and then w would have the value 0.3. So here you go. And then that's repeated for each element. So now what we can do is we can simply multiply x times w, and that is what we have done here. We have multiplied x times w, so 73 times 0.3, 67.2 and 43 times 0.5, and we have added them into the result. So in effect, it has the exact same effect as what we had done earlier. So temperature multiplied by W1, rainfall multiplied by W2, humidity multiplied by W3, and then we return the result. All right. So that's our crop yield function, and we can verify that we call crop yield with the Cantor region and the same weights, and we get back the same result, 56.8 tons per hectare. And we can do the same thing for the Johto region and for the Unova region. So already we've simplified things a bit by writing this function. Now the calculation that we've performed, the element wise multiplication of two vectors and then followed by a sum of the results, this is also called the dot product of two vectors. And this is just a linear algebra term, and the dot product means exactly what I just said, an element wise multiplication of two vectors followed by a sum of the results. And you can learn more about dot products here on Khan Academy. It's a great resource if you just want to brush up linear algebra in general. But now the NumPy library, which is specialized for doing numerical computing and performing operations on numerical data, provides a built-in function to perform the dot product of two vectors, because this is such a common operation. But to do that, the lists that we have, the data that we have, must first be converted into a special data structure called NumPy arrays. And to create NumPy arrays, we first need to import the NumPy module. So I already have the Python library NumPy installed. This was done when we clicked the run button. So there was a set of requirements with the Jupyter Notebook. But if you do not have NumPy installed, you can do pip install NumPy minus upgrade and minus quiet. And this is just to suppress the output, but pip install NumPy should do it. So you can run this to install NumPy, and don't forget the exclamation character. But now we import NumPy as NP. And now the NumPy arrays can be created using the np.array function. All right. So if you're seeing this part for the first time, so all we're doing here is we're saying that we want to import the NumPy module, but instead of calling it NumPy, we want to call it NP, so that when we want to use the array function from NumPy, instead of writing NumPy.array, we can just write NP.array. So this is also called aliasing. Okay. So now we create the Cantor region, the data we simply call NumPy.array, and then we just pass in the same list of numbers that we had earlier. So nothing is really changed yet. And you can see here, we print it out and we can just see that this is a NumPy array with the same list of numbers. Then we have the weights. So this is once again a NumPy array. It simply contains a list of numbers. But when you check the type, you will see that each of these has the type ND array, right? So this is no longer a Python list. This is now a special data type which is defined and offered by NumPy. Okay. And just lists, the NumPy arrays behave like lists in many ways. And one of the ways is just the indexing notation. So if you just use the indexing notation, you can get back the 0th element, which is 0.3 from weights, or the second element, which is 43 from Cantor. But they also differ from Python lists in many important ways. And that is what we are going to see next. Okay. So now remember, we wanted to compute the dot product, which is the element wise multiplication followed by a sum of the results. We can do that using the np.dot function. And a good way to see what the np.dot function does is just say help np.dot, and that's going to tell you what it does. So there's a lot of documentation here, and it gives you a lot of information about it. And then at the bottom, you will see a bunch of examples as well. So you can just see how to use this function. So now we call np.dot with Cantor and weights, and we get back the same result, 56.8. except that now we just need to write this single line of code. If we can actually achieve the same result with even lower level operations. So NumPy arrays support arithmetic operators. So here if we simply do Canto, let's just